Okay, so picking up where we left off, hopefully you're good up to there. If not, you should go and get help before you keep going. As soon as we have that first, it's not always the first column, but as soon as we have a column complete, where like an HCl in this case, we have the moles, the change, and it ends at 0. As soon as we have that completed column, we can find out what our X value is. Once we have our X value, we can finish this whole chart. We can plug in numbers everywhere. And once we have this whole chart finished, we're really close to being done with the problem. So what I do now is I pretend that this column is really an algebraic expression. So I'm going to rewrite this kind of horizontally, 1.36 minus X, and then it always equals what we have at the end. So 1.36 minus X, and then equals equals the E, equals what's at the end. Solving this for X, we get our X value is 1.36. And that basically shows us how quickly we're using up or making each product or reactant. I'm not going to actually replace my X's, but what I am going to do is go and know that I can plug that X into each of these X's so that I can then figure out what's at the end for each compound. So for the NaOH, it's 1.5 initially, but then it says we subtract 1.36. So to figure out what goes at the end here, I'm doing 1.5 minus my X value. 1.5 minus 1.36. So at the end, I still have some NaOH left over. I didn't use it all up. I just can't keep making any more product because I ran out of HCl. I have 0.14 moles of NaOH left. For NaCl, I start with nothing, but then I add my X value. I add 1.36, so I end up, it turns out I made 1.36 moles of NaCl. For my water, I start with 0, I add my X, which is 1.36. It turns out I have 1.36 moles of water at the end. So now if I look back at my questions, now that my ice chart is done, part B, finding the mass of water produced, is actually pretty simple. Because I look over at the water column, HOH, it says I have 1.36. Remember, this whole chart is in moles. Well, if they want the mass, they want grams. Grams of water equals moles of water times molecular weight of water. I have 1.36 moles of water at the end of this reaction. Molecular weight of water, sorry, I'll make that a little neater for you. The molecular weight of water is 18. So when I do that multiplication, 1.36 times 18, I get 24.48. You want to say 24.5, fine. 24.5 grams of water. So part B is really easy once we have this whole ice chart filled out. For part C, where it asks for the grams or the mass of the excess reactant remaining, think about what those words mean. Excess means extra. Reactant, so those are things on the left of the arrow. Remaining, meaning at the end. So how much of the reactant that we didn't run out of do we still have left? Well, the reactant we didn't run out of is NaOH. NaOH is a reactant, it's on the left of the arrow. So HCl is also a reactant, but we ran out of the HCl. We didn't run out of the NaOH, we still have some of it left. But again, everything in this chart is in moles. So if I want to turn that into grams, grams equals moles times molecular weight. We're finding the grams of NaOH because that's our reactant we still have some of. We have 0.14 moles of it. Molecular weight of NaOH is 23 plus 16 plus 1 is 40. So we have 5.6 grams of NaOH that are still left over in our pantry. Cool, go try finishing the one you started before, and then we'll look at one with coefficients.